Most services do two separate commits. They save order 1042 to Postgres, then publish an order-created event to Kafka. It looks atomic from the outside, but it isn't. A crash, a network blip, or a rogue retree can strike in the millisecond between them. The order is saved. The event never leaves. Downstream inventory, billing, and fulfillment never see the change. That gap between two commits is where your consistency dies, silently. The transactional outbox pattern collapses that dual write into a single local ACI'd transaction. Zoom into the database. Two tables sit side by side, orders and outbox. A glowing transaction boundary wraps both and labels them same TX. When the app updates order 1042 to status paid, it simultaneously inserts an order-created event row into outbox. One commit, one green check mark. Both rows succeed together or fail together. You never get an order saved without its matching event row, and never an event row without the order. The database stays the single source of truth, then a separate relay process, decoupled from the application, polls or tails the outbox and publishes the event to Kafka. Because publishing happens after the commit, a broker hiccup cannot roll back the order. The event simply waits in the outbox until the relay retries. Here is the real insight. Outbox does not guarantee exactly once delivery. It guarantees atomic origin plus at least once relay. The event is born inside the database transaction, but after that, networks retrieves, and relay restarts can send it twice. Every consumer must be idempotent. They deduplicate using idempotency keys, natural key checks, or fixed-size deduplication windows. The relay itself is the main architectural choice. A polling relay repeatedly runs select against the outbox. Operationally simple, but it adds latency and increases database load. A well-based CDC relay like Debezium reads the database transaction log, the PostgreSQL or MySQL bin log directly. Lower latency, true commit order, but extra infrastructure and database-specific wiring. Shopify runs this in order flows, so a MySQL commit reliably triggers inventory, billing, and fulfillment. Pick the relay that matches your latency and operational budget. The most common failure mode is not the relay breaking. It is teams treating the outbox like a fire and forget queue. They skip retention policies, forget automated cleanup, ignore back pressure, and tightly couple event schemas to table columns. The table grows downward forever. Without bounds, queries slow, and a stuck relay that recovers can replay a thundering herd. Use outbox when probably delivered is not good enough, but operate it like a real queue, set retention, automate cleanup, scope ordering to an aggregate or partition, and choose your relay deliberately. Otherwise, you trade one consistency problem for an operational one.